Good morning, students. I welcome you to the second session of mine on stoichiometry. This is the class for first semester students of Modern Science College Autonomous, Mysore. In the first session, we discussed about the definition of stoichiometry. Then we looked at the definitions of atomic mass and molecular mass. We learned that stoichiometry deals with the quantitative study of reactants and products in a chemical reaction. So with that background, today we shall move on to the concept of mole. You have learned in your earlier classes about 7 fundamental units of SI system. So one of the 7 fundamental units is mole. Like you have fundamental SI unit for time, second, SI unit of length is meter, SI unit of mass is kilogram, SI unit of intensity of light is candela, etc. And SI unit of temperature is Kelvin. Like that, the fundamental unit for quantity of substance is mole. So the spelling is written as MOLE, but when it's written as a unit, we write 1 mole. So when I say 1 mole of sodium chloride, I can write this. Or I can also write like this. But if you say 10 moles of sodium chloride, it will be can be written like this, 10 moles of sodium chloride, or you write it as full words, 10 moles of sodium chloride. So this is a mole is the fundamental unit of amount of substance. So what is the definition of this mole? So as we learned in the earlier section that atomic masses and molecular masses were calculated considering C12 isotope as a reference. Similarly, mole is defined considering C12 isotope as a reference. So what is mole? How do we define? Mole is nothing but amount of a substance containing as many atoms or molecules or ions or particles as there are atoms in 12 grams of C12 isotope. So this is the definition. So mole is defined as amount of a substance containing as many atoms or molecules or ions or entities or in general we say entities as there are atoms in 12 grams of C12 isotope. In the sense, any substance containing particles equal to the number of C12 atoms in 12 grams of C12 sample. Why is it taken as C12? Because that is taken as a reference by the chemists or scientists around the world, and IUPAC has accepted this. So, since C12 isotope is taken as reference for atomic and molecular masses, same isotope is taken as a reference for defining mole. So, if you consider 12 grams of C12 sample, means there is nothing, there are no C13 or C14 isotopes. If you take natural C carbon sample, natural carbon ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ C12 ಇರುತ್ತೆ, C13 ಇರುತ್ತೆ, C14 ಇರುತ್ತೆ. ಸೊ ಅಂತ ನ್ಯಾಚುರಲ್ ಕಾರ್ಬನ್ ಇಂದ C12 ಐಸೋಟೋಪ್ ಕಂಪ್ಲೀಟ್ ಐಸೋಲೇಟ್ ಮಾಡಿ 12 grams ತಗೊಂಡ್ರೆ. So that's the meaning. So if you take 12 grams of C12 isotope, so the number of atoms In C12, in the number of atoms in 12 grams of C12 is equal to 12 grams per mole. 12 grams divided by 1, the mass of C12 atom. So this gives you the number of atoms in 12 grams. So what is the mass of one carbon atom? C12 atom. So this mass is found to be 1.992648 into 10 to the power minus 23 grams. So this mass of C12 atom is found accurately from mass spectrometer, and mass of single atom of carbon 12 isotope is equal to this. So when we simplify this comes to be 6.022137 into 10 to the power 23. So when we look at this ratio, how do we calculate? The number of atoms in 12 grams of C12 isotope is equal to 12 grams divided by mass of one C12 atom, and this mass of one C12 atom is found accurately from the mass spectrometer technique, which is 1.992648 into 10 to the power 23 grams. So when you simplify this, you get this number. So this is the number of carbon atoms present in 12 grams of C12 sample. So this is taken as a standard, and this number nowadays is called as Avogadro number. So this is denoted by NA. In some books they simply stand for N, in some books it's written as NA, so it's better take N as Avogadro number. So in general, Avogadro number is considered as 6.02 into 10 to the power 23 per mole. Okay, so many particles are present in 1 mole of the substance. So mole is defined as amount of a substance containing as many atoms or molecules or ions or particles as there are atoms of carbon in 12 grams of C12 sample. So 12 grams C12 sample ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಯಾವುದೇ ಸಬ್ಸ್ಟಾನ್ಸ್ ಅಲ್ಲಿ ಇಷ್ಟು ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ರೆ ಆ ಅಮೌಂಟ್ 1 ಮೋಲ್ ಅಂತ ಕರೀತೀವಿ. So if you consider now, so if the concept of mole is understood by you, so this mole is taken as SI unit for amount of substance. This is one of the basic units among the 7 basic fundamental units of SI system. So once you understand that any quantity, the quantity of any substance containing 6.202 into 10 to the power 23 number of particles is called as 1 mole. So if you consider 1 mole of sodium or 1 mole of HCl or 1 mole of any compound, in order to calculate the mass of 1 mole, which is called as molar mass, we have already discussed about atomic mass and molecular mass. Okay, so molecular mass is calculated by summing up the atomic masses of all the atoms present in the molecule. So if you consider simple molecule like water, so molecular mass of water is equal to sum of the atomic masses of so it's sum of the atomic masses of hydrogen also present in water. So atomic mass of hydrogen is 1.0082 atomic mass unified mass plus 16 into 1 into 16 atomic mass of oxygen. So this is around 18.008 U. This is a molecular mass. So when I say this is not in grams or milligrams, it is in terms of unified mass. If you convert it to grams, as I already learned, One unified mass is equal to 1.66 into 10 to the power minus 24 grams. So this is the mass of one molecule of water in terms of gram, and this is the mass of one molecule of water in terms of unified mass. So this is the mass of one molecule of water. So if you consider mass of 1 mole of water, what's 1 mole? I already learned. So if I say 1 mole of water, it is that amount of water containing 6.022 into 10 to the power 23 number of water molecules. So we have already learned the definition of a mole. So when I say 1 mole of water means amount of water containing 6.02 into 10 to the power 23 molecules of water. So this mass of 1 mole of water would be equal to 80 grams. So if you just replace U by G, you get the molar mass. So if you take 18 grams of water, this 18 grams of water will contain 6.02 into 10 to the power 23 molecules of water. So 18 grams is called as a molar mass. So molar mass is nothing but mass of 1 mole of a substance. What was 1 mole of a substance? 1 mole of a substance is that amount containing Avogadro number of particles. So if the concept of mole is clear, now after understanding the concept of mole, let us try to calculate or convert moles to mass, or mass to moles, or moles to number of molecules. For example, take sodium. Atomic mass of sodium is 23. Means one atom of sodium weighs 23 AMU. So this is atomic mass of sodium is equal to 23 U. Atomic mass units. Now, if I take 1 mole of sodium, which is also called as gram atom of sodium, so 1 mole of sodium, which is also called as gram atom of sodium, is equal to 23 grams. So 1 mole of sodium weighs 23 grams. In the sense, 23 grams of sodium contains 6.02 into 23 atoms of sodium. So now 23 grams sodium metal, now pure metal we ಮಾಡಿ 23 grams ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ಎಷ್ಟು sodium atoms ಇರುತ್ತೆ is static. So 1 mole is immediately should come to your mind the Avogadro number. Whenever you hear the term mole, it should immediately come to your mind. It is nothing but 6.022 into 10 to the power 23. That number is called Avogadro number. Now, so 1 mole of sodium is equal to 6.02 into 10 to the power 23 atoms, and in terms of mass it will be equal to 23 grams. Now if I say, what is the mass of, calculate the mass and number of atoms of sodium is 2.3 grams. If you consider, calculate the mass, mass and number of atoms of sodium in 0.5 moles of sodium. Now let us see. So you have 0.5 moles of sodium. So our duty is to calculate, our problem is to calculate what is the mass of 0.5 moles of sodium and how many number of atoms of sodium will be present in 0.5 moles of sodium. So we know mass of 1 mole of sodium is equal to 23 grams. That's 1 gram atom. So mass of 0.5 moles of sodium is equal to, it is 0.5 into 23 by 1. So this becomes 11.5 grams. So mass of 0.5 moles of sodium is 11.5 grams. The problem is not over here. Now we have to calculate number of atoms of sodium in 0.5 moles. So we know 1 mole of sodium contains 6.022 into 10 to the power 23 atoms. Therefore, 0.5 moles of sodium contains how many? So 0.5 into 6.022 into 10 to the power 23 by 1. So half of this is 3.0, sorry, by 2 is 3011 into 10 to the power 23. So this is how we can, with the knowledge of concept of mole, we can tackle the problems pertaining to the calculation of number of moles, number of molecules or the mass. Now let us take up one more example. Calculate the mass of 10 to the power 20 molecules of water. Let us see. Calculate the mass of 10 to the power 20 molecules of water. So what is the solution? How do we proceed? We know 6.022 into 10 to the power 23 molecules of water have a mass equal to 18 grams. We know that because molecular mass of what is 18, so molar mass of what is 18 grams. When I say molar mass of what is 18 grams, 18 grams of water contains a large number of molecules. So when so many molecules of water weigh 18 grams, what will be the weight of 10 to the power 20? Say one side 10 to the power is nothing but 1 into 10 power 20. So this would be equal to 1 into 10 to the power 20 into 18 grams divided by 6.022 into 10 to the power 23. If you simplify this, you get the answer. And you can simplify it, you can try another one. So roughly, if I take the 6, so 10 to the power 20 goes to the numerator, it becomes minus 23. So I can write this as 10 to the power minus 23. So 10 to the power 20 into 10 to the minus 23 is 10 to the power minus 3. And 18 over 6.02 roughly it can be taken as 3. So it is roughly 3 into 10 to the power minus 3 grams. We can also add one more question tag to this. Calculate the mass and the number of moles. So ಇವತ್ತು ಮಾಡಬಹುದು. ಹೇಗೆ? How many number of moles are present in 10 to the power 20 molecules of water? So 1 mole of water contains 6.022 into 10 to the power 23 molecules. So 1 mole corresponds to that quantity 6.022 into 10 to the power 23. Now 10 to the power 20 molecules correspond to how many moles? Very simple problem. Simple when one understands the concept of the mole. Otherwise, it will be difficult. So, 6.022 divided by the molecules correspond to 1 mole. So, 10 parts of the molecules correspond to how many moles? So, this will be equal to 10 to the power 20 into 1 divided by 6.022 into 10 to the power 23. So, that will give you so many moles. So, 10 to the power 20 molecules of water correspond to so many moles. So this is how we can calculate or convert mass to molecules, moles to mass to molecules or mole to molecules. Let us consider the last example so that there will be clarity regarding the concept of mole. For example, if you consider sulfuric acid. Let us see what will be the molecular mass of this. So molecular mass of either sulfuric acid is there are two atoms of hydrogen, 2 into 1 plus atomic mass of sulfur is 32. There is one atom of sulfur and atomic mass of oxygen is 16 and there are 4. So you have 2 plus 32 plus 64 is 98. So molecular mass of sulfuric acid is 98 U. If converting to grams is 98 into 1.66 into 10 to the power minus 24 grams. You can also do that. And students have got confusion. When I say molar mass or gram molecular mass, they say that molar mass is nothing but molecular mass expressed in grams. That's wrong. Molar mass is the mass of 1 mole of a substance. Gram atom is not the atomic mass expressed in grams, but it is the mass of 1 mole of atoms of that element. So please be careful about the definitions. Many times, even some books they say molar mass is the molecular mass expressed in grams. That's wrong. Molar mass is the mass of 1 mole of a substance. Okay, numerically that will be equivalent to atomic molecular mass expressed in grams, but that's not the definition. So right, so molecular mass of sulfuric acid is 98. So molar mass of sulfuric acid what is the unit of molar mass? 98 gram per mole. This is the unit of molar mass. So 1 mole of sulfuric acid is 98 grams. Now let us see what is the mass of say 10 to the power say 1.5 into 10 to the power 10 molecules. Very simple. So now we have to calculate mass of 1.5 to 10 to the power 10 molecules. So how do we proceed? We know molar mass of sulfuric acid is 98 gram per mole. So 6.022 into 10 to the power 23 molecules correspond to 98 grams. So what will be the mass of 1.5 into 10 to the power 10 molecules? So this would be equal to 1.5 into 10 to the power 10 into 98 grams divided by 6.022 into 10 to the power 23. Our number is per mole. 6.022 into 10 to the power. This is per mole. Okay, so when you simplify this, you get the answer. 6. You get the mass of so much. You can also calculate number of molecules. Number of moles. Okay, molecules is the number of moles of sulfuric acid. What is this? This is equal to what? Number of molecules divided by Avogadro number. So number of molecules is 1.5 into 10 to the power 10. our order number is 6.02 to the power 33. So this ratio upon simplification gives the number of molecules. We can also calculate number of atoms of sulfur or atoms of oxygen in a 1.5 to 10 to the power 10 molecules. We have calculated mass of so many molecules. We have also calculated number of moles of in so many molecules. Now we can also calculate number of oxygen atoms in so many moles or so many molecules. So how do we calculate number of atoms? Each molecule of sulfuric acid consists of 4 atoms. So number of atoms would be equal to 1.5 into 10 to the power 10 molecules. Because we are supposed to calculate number of atoms in so many number of atoms of oxygen in so many molecules. So it will be 1.5 into 10 to the power 10 molecules into 4 atoms per molecule. Because each molecule of sulfuric acid contains 4 oxygen atoms. So if you simplify this, 6 into 10 to the power 10 atoms. We can also calculate how many moles of oxygen atoms are present in so many molecules. See, the problem can be tackled in whatever it is asked if you have clear understanding of the concept. Now I change. Instead of asking number of atoms of oxygen in so many molecules, I can also ask how many moles of oxygen atoms are present in so many molecules. How do we do that? We have already calculated number of moles of sulfuric acid in so many molecules. These so many moles. Now I asked how many moles of oxygen atoms are present in so many number of molecules. So number of molecules will be equal to this number of moles. So many moles, and each molecule contains 4 atoms. So many moles will contain 4 times the moles of oxygen atoms. If it is a number of hydrogen molecules, it will be half of the number of oxygen atoms. If it is number of sulfur atoms, it will be 1/4 number of oxygen atoms. So this is how, if we have a clear understanding of mole concept, we can calculate either mass or number of molecules, etc. etc. Thank you.